Hi, this is our second video about acids and bases, and we're going to look today at neutralization reactions. All right, an acid-base reaction is a double replacement reaction, and it produces a salt and water, and that's why they call it neutralization. It's like you neutralize the acid and the base. So let's go ahead and have a pretty good look at these. Hydrochloric acid, HCl, and sodium hydroxide. So again, the double replacement, this H goes with the OH and that Na goes with the Cl. And so our products are sodium chloride, that's a salt, and HOH, also known as H2O. When we say a salt, it doesn't necessarily have to be sodium chloride like our table salt. It could be just an ionic compound where we have a metal and a nonmetal. So acid-base reactions are called neutralization reactions because basically you took an acid, you reacted it with a base, and you got something that was neutral. You got a salt and you got water. All right, now we're going to talk about titrations because we're going to do a lab tomorrow with acid-base titrations. Now, a titration is defined as delivering a solution and you know its concentration, and you're trying to figure out the concentration of an unknown solution. And we use a fancy thing called a burette, which is kind of fun to use. So, titrations are used to determine the concentration of something using something where you know its concentration. All right, so the setup looks something like this. This long tube is called a burette. You can put the acid or the base in the burette, it doesn't matter. It has this little tap here to turn it on and off, and then there's this stem down here. And then normally we titrate into an Erlenmeyer flask, and you've got a solution down here that has an indicator in it that will change color. All right. So let's go ahead and do some practicing with acid-base titrations. Now, what volume of 0.1 molar hydrochloric acid is needed to neutralize 25 mils of 0.3 molar sodium hydroxide? Well, when we do this, the first thing we need to do is make sure that we can write a balanced equation. So this equation is the same one that we had earlier, and so we get sodium chloride and water, and it is balanced with a coefficient of 1 out in front of everything. That 1 is understood. What I like to do, after writing the balanced equation, I like to put all my information under my balanced equation. So on my acid side, I've got 0.1 molar, and they want to know what volume of it to neutralize the 0.35 molar NaOH, and we have 25 milliliters of it. So in my problem, here is all the acid stuff, and then here is the base stuff. All right, so that's my base stuff. All right, now, when moles of acid equals moles of base, we say this reaction is at its equivalence point. So equivalence point, that is when the moles of acid equal the moles of base. All right, we also see this molarity up here, and if you remember, molarity is moles per liter. All right, now, we could also say that a mole is equal to molarity times our volume in liters. Well, at our equivalence point, the moles of our acid equal moles of our base. Or we could say the moles of our acid, and then we could just say the volume of the acid. Doesn't have to necessarily be in liters if we are setting it equal to the molarity of the base times the volume of the base. What's important about our volume unit is that it match on each side. So if we use liters, that's great, as long as you had liters over here. Or if you used milliliters, that's fine too, as long as the volume over here was in milliliters. All right, now, the one thing we need to add to this is out front of this, you need to write with your acid the number of H's that you have. And in front of the base, we need to write the number of hydroxide ions you have. All right, let's go ahead and do this problem. All right, so our molarity of our acid is 0.1 molar. The volume of our acid is what we want to know, and the number of H's that we have in HCl is just 1. Okay, our molarity of our base is 0.350 molar. The volume of our base is 25 milliliters, and our number of hydroxide ions in sodium hydroxide is just 1. So here we go. MaVa, and remembering number of hydrogens out front, which is just a 1 in this case, is equal to the number of hydroxide ions times molarity of our base, volume of our base. Well, molarity of our acid is 0.1 molar. Number of hydrogens, a 1. Our volume of our acid is what we're solving for. Our number of hydroxide ions is a 1. Our molarity of our base is 0.350 molar. And our volume of our base is 25 milliliters. And we can leave it in milliliters. And then when we solve for this volume of A, its volume will be milliliters. So when I do this little bit of math, what I get is 87.5, and that's in milliliters. Wow, this is a pretty useful equation. All right, let's look at this one. You have 25 mils of hydrochloric acid, so this is our acid stuff. And this is our base stuff. We've got 24.16 milliliters of 0.106 molar hydrochloric or sodium hydroxide. So the molarity of our acid times the volume of our acid is equal to the molarity of our base times the volume of our base. Our number of hydroxide ions is 1. How many H's are in hydrochloric acid? 1. It's the same balanced equation that we've been using. So here we go. Molarity of our HCl. That's what we're looking for. Our volume is 25 milliliters. All right, the molarity of our base is 0.106. And the volume of our base is 24.16 milliliters. All right, the molarity of our acid is, when we do this, it's about, let's see, it's going to be 0.102 molar. It's the molarity of our acid. Okay, that's it. Well, we're going to do titrations in the lab tomorrow, and you are going to need to find out the concentration of acid, and I'm going to give you sodium hydroxide, and I'll tell you its concentration. You should like the lab. All right, we'll see you later.